Problem number 5. Let's look at the specification. So this problem here is really solving some more generalized problem about checking existential versus universal properties. And we'll only look at it checking the universal properties. You can actually work out another example symmetrically for existential property. Let's read the problem description here. Given an input 2D array of integers, we want to determine if elements in the 2D array are all positive. So whenever you want to check to see if all the elements are satisfying a particular property, we say that it's like a universal property. So it must be universally true. And existential property will be just the opposite idea. Will be at least one elements in the array or in the input should be satisfying the property. But that's not what we are talking about in this problem here. Let's focus on just universal property. Let me remind you quickly. So all positive over here. So whenever you see the idea about all elements in the input should be satisfying, the property is called universal property checking. So universal property. Universal property. And the principle of solving it in the context of 2D arrays will be exactly the same as how you did it for the one-dimensional array. The idea will be as soon as you find out if there's any violation witness, you're going to conclude it is not the case that all are positive. Specifically, as soon as you find out anything that's not positive, you will know that it's not the case that all the elements are positive. Otherwise, you have to go through the entire array to really see. So what we really want to do is to implement an algorithm, a method that's as efficient as possible. So here the efficiency will be defined by the number of iterations for the loop, specifically the nested loop. And we are going to use so-called early exit idea, which we spoke about in the case of one-dimensional array. However, we really don't want to use any break statements. So the break statement, which we didn't cover in this course, but some of you might know this maybe from another language, either from the C language or maybe other language. Break statement might make your code work. However, it will not scale up to some large system. So does not scale. And also worse, you can also feel free to do a little bit of research, but we're not going to cover that in detail in the tutorial video. For the break statement, it's also known to really cause your code to be so-called spaghetti code, like an Euro structure code. Because if you got too many break statement in your large number of lines of code in your class or in your method, it will be difficult to really trace your code by having so many break statements. So that's kind of the practice I would like to discourage you to do by using the break statement. So that's why in this course we actually show to you how to use the Boolean variables to really control the entrance or exit for the loops. In that case, it will be much easier to really do some informal justification why your algorithm, your loops actually is working correctly. All right, so that's something I want to put it mention aside. I will really discourage you to really try to implement your universal property checking using a break statement. That's really highly discouraged. Okay, so now for the universal property, the main principle really is as soon as a violation witness is found. For example, in the case of checking the property of the element being positive, what would be a violation witness? Which means it is not positive, or less than or equal to 0. So that would mean it's a violation witness. As soon as we find such violation witness, so we can conclude. Exit and conclude. False. False in the sense that the universal property is actually not satisfied. Otherwise, if you just cannot find such a violation witness, then you can definitely conclude true after you have verified all the elements in the array. So that'll be the principle I want to remind you quickly. All right, let's look at the two inputs we would like to consider for this problem here. So let's say for this particular array, and we don't really make any assumption about the shape for the input array. So it can be rectangular, or it can be simply Euro structured, like a irregular shape over here. And for this particular array, can you find any violation witness that will prove not all the elements are positive? The answer is no, because all the elements over here are simply just positive. So the answer will just be true. Okay, so just put it aside. Okay, so this will be true. On the other hand, what about the second input array? Are all the elements positive? So now, can we find any violation witness? The answer is yes. As soon as we have seen -4 in our loop, in that case, we can conclude from this point onwards, we don't really need to check any further. Of course, in this case, you only got 2 elements remaining, but we can at least save 2 iterations. But if you actually find the violation witness in another input much earlier, for example, maybe only in the earlier elements you have found the violation witness, in that case, you can definitely your code will definitely run more efficiently if you can early exit. All right, so let me just make a note over here. So -4 over here will be the violation witness, -4. Okay, let me just make a connection here. So -4 would be the violation witness. Violation witness. Okay, so enough about the problem description. The problem itself is not really difficult, but the main point is to remind you about how you can check universal properties. And then at the end of the video, I'll give you some more challenging exercise to see how you can solve it, right? Since we got 2 dimensions to consider, so we can definitely consider some extra complication. But let's do the easy thing first together. All right, let me now move on, move back to Eclipse, and then let's now, first of all, document what should be achieved using the test case. So let's now, before we do that, we definitely have to declare the header of the methods. Maximize the utilities, and then let's now declare the method over here. Let's follow from the previous solution. So let's say public, and then static, and we want to determine whether or not all the elements are positive. So whether or not itself tells you it should be a Boolean return type. So we'll say Boolean over here. And then let's say are all positive. All right. Okay, so that's so the all over here tells you it should be universal property. Okay, and then input would just be an array A of integer, and then let's say by default we'll just return false. Okay, before we code it up, we will document what to be achieved by calling this method. Let me now go to test utilities, and then let's now document the test case first. Okay, I'm just going to reuse maybe test number 5 over here, but I will change the contents for the array, of course, but just save some typing for us. All right, let me now try to put it in the middle over here. Okay, and then it should be number 7, okay, for our problem. Okay, so input number 1 should be exactly this array over here. This array over here. Let's see what we should change. So we got 1, 10, 5, 7. We got 6, 2, 12, 9, and also 3, 8, 4, 11. So this one is okay, right? However, we want to make sure you actually call the correct method from the utility class. So are all positive, right? And then it's going to take input 1. And then the output from there should be, not rather than one-dimensional array, it should be a Boolean. And the expected result should be true. Because you can see that in this particular array over here, we know that every element over there should be positive. On the other hand, the second input we're going to try, it should give us false, because there is at least one violation witness. So let me also write it down over here. So for this one here, it's going to be false for this one here. Okay. Okay, let's go back to the JUnit test. Okay, so now we can simply say assert equals, since we are not comparing arrays. So expected 1 and output 1, right? That's good. What about the second array? The second array is going to be, let's say this one here. It's going to be 10, 10, 10, 10, 41, -4, 29, 13. Okay, let's now do it. So I'm just going to say over here 10, 10, 10, 10. The exact value doesn't really matter. I just want to map to the what's on the paper. But you can definitely try out different inputs. You're encouraged to do so. And then 41. And then we got -4, and also 29, and also 13. All right, and then output number 2 is going to be a Boolean, and then we're going to call R all positive with input 2 actually. And then what about expected 2? It should also be a Boolean. And then this one here, rather than true, it should be false, right? Because we can find at least one violation witness, which I just spoke about. All right, and then it's going to be assert equals over here. All right, so that's about what should be achieved. Let's now code up to be about how we can achieve it of the utility method. Let's go back to utility method here. And then the idea will be very similar to when you program the one-dimensional array, very similar. So we just need one Boolean variable like this. Let me declare that first. Boolean, all positive. And we set in the lecture already. So initially it should be simply all positive should just be true. You can think about alternatively, you can think about intuitively actually. You can think about this Boolean variable simply means, have we found any violation witness? Initially, we haven't really started scanning through the array, so we have not found any violation witness. So that is why all positive should be true. As soon as we have found any violation witness, for example, the -4 in this particular array over here. So as soon as we find such violation witness, we're going to set this Boolean value here to be false. In that case, it should also consequently cause the 2 nested loop to really exit right away. So we are not going to use a break statement. As I said, it's not a recommended practice for you. So you should really you're encouraged to really try to use a Boolean variable, which will make it easier for us to judge the correctness of your code logically. Okay, so now let's code up the loop. It's going to be a nested loop, of course, to go over every element. I will talk about extended state condition in a moment. Let's just scan it through. So now for integer, row initialized to be 0, row less than a.length, and also r++, right? Very standard. And then integer colon initialized to be 0, c less than, and a index r dot length, right? Oh, sorry, wrong one. And then c++, right? That's about how you do it. And then we can say for each element it's going to be arc, right? And then we want to see whether or not it is positive, right? And then we want to assign this particular Boolean expression to this all positive, right? And we don't really need to accumulate it because we want to early exit as soon as we have found. So as soon as all positive has become false, it will be time to really early exit from the loop. Okay, so now we should really extend the state condition over here and also over here, right? That's something we have done in the lecture. So what we can do is we can say all positive over here and like that. And then I will remind you intuitively what this really means in just a moment. Okay, and then also all positive over here. Yeah, it's just a typo. All right, let's now, let me just fix it again. And also conjunction over here. Right, let's now try to read it together and then see what it means intuitively. Intuitively, we are saying this. We're going to keep executing the body implementation of the outer loop as long as all positive remains true. And also R is a valid index for the row. And also we say that we're going to execute the body of implementation for the inner loop as long as all positive remains true. And also the colon is actually a valid index for the second dimension array, right? The second for the arrays in the second dimension. As soon as all positive is assigned to false, it's going to, number one, it's going to cause this expression to be false, meaning that this part for the state condition will be false because we're using a conjunction. And then after we exit from this particular inner loop, we're also going to check the header for the outer loop again. to see if we should really go for another iteration. But since all positive is really the same value, is the same variable that has been assigned to false already, so it's also going to cause the conjunction to be false. So that means we're also going to exit from the outer loop without executing any further. So it's a really nice logical manipulation over here. As soon as this particular Boolean variable, which is used in the conjunction of the two state conditions for the outer and inner loops, as soon as it becomes false, it's going to exit from the two loops right away, right, without going any further. That's exactly what we want. Okay, so that's something I want to remind you. All right, and then after this, we can simply say return all positive. All right, so that would be the solution, I think. Let's now try to run the test case over here to make sure it works. All right, green bar. Okay. Another way to do it would be, if you really want to get rid of the all positive and all positive, another way to do it, let me just show you the alternative solution, okay, quickly. I can simply comment this out, and then let's say we don't want any early exit. Let's say we can get rid of this, and we can get rid of this. However, this one is actually logically wrong, because so that means all positive is going to be just the value of the last reassigned value. It's gonna the last reassigned value based on the last element. That's something we discussed in the lecture, so I wouldn't really go over that again in the tutorial. So let's try again. Let's say this version is actually wrong. Let's see if we will still pass the JUnit test. If I simply run the JUnit test, you can see we get a red bar, right? Apparently that this particular version, without any accumulation in the body of implementation here, and also without any control of early exit, is simply wrong, right? It will be an exercise for you. Okay, so I would say exercise. This is something we already did in the lecture, so I just want you to think about it in the context of two-dimensional array. Exercise: why writing this particular line is going to fail the test. Will fail the test. So that's an important question for you. Why this version is wrong? So what will be the correct version? The correct version should be, we should make sure every time we check not just the last elements in the two-dimensional array, but also every element in the array. So we want to keep accumulating the result. So all positive should also appear over here and using conjunction, since we're doing universal property checking. So this will also work. So now if I try to run the test, so we get a green bar again. All right. So I got two working versions here, either with early exit or without the early exit. Okay, it's up to you which one you want. Later on in the second year, you will learn about, even though we got strictly, very often we got strictly fewer iterations to run. So you think that's actually more efficient. However, asymptotically, as you will learn in the second year, they are equally efficient when the input size is very large towards infinity mathematically. But that's something we wouldn't touch in the first year. I just want to give you a little bit of heads up for what you're going to see in the second year. All right, let's go back to, so we are done with the solution and also the test for problem number 5. Let me give you some more challenging exercise for you to try, okay? Since now we got 2 dimensions, so we can somehow mix the existential property and also universal property. We can say we want to check for existential property in the first dimension, whereas we want to check the universal property at the second dimension. So what do I mean? Let me put the exercise over here for you. Okay, let me put it here. So let me just write in this one, let's say exercise. So you want to implement a method in the following way. Okay, determine if there is at least one row whose elements are all positive. If that's the case, you say true. Otherwise, you say false, right? Let's now analyze this problem statement a little bit to help you, okay? So when we say at least one row, so this apparently is existential. existential check on the first dimension, right? Because you're talking about the row. Whereas if you talk about, let's say here, let me use pink. Let me use another one. Let's say orange. All positive. So here, this is about the second dimension. So this is something for universal checking. Universal checking, and it's about the second dimension, colon, more precisely. Okay, let's just go over these two examples very quickly. So now, if you look at that, is there at least one row over here that actually all the elements are positive? Indeed. So now, how do you find out at least one row? Give that such row. So you can give a witness, satisfaction witness over here. So for example, this will be such row. This will be the row, at least, this is the at least one row that will actually got all the elements positive. So this for this new problem here, this input should really give you true. On the other hand, what about the second input over here? Is there at least one row that will actually got all the elements positive? Indeed. What about the first one over here? You can see the first row got 10, 10, 10, 10. So that one there is actually going to give you also true. You can see in this case, the answer will be different from the original problem over here. So that's why this will be worth doing. So you're not really getting the same results. So applying just the same algorithm that we just implemented wouldn't just work directly. All right. So guys, I think this will be a very important exercise for you to try. Okay, so this will only maybe require maybe a little bit of extension to the method over here. You can try it out, and then it will be up to you to really finish this and make sure it is correct. And then if you got any trouble, you can get in touch with me, and then we can work out your solution together. All right, so that's about problem number 5. Let's now move on to the next problem.